Let's talk about MATLAB's matrices and arrays. A equal to ran 3, 3 produces a random matrix whose entries are all random numbers. A uniform random variable is used for generating the entries of A. The uniform random variable lies between 0 and 1. It's a 3 by 3 random matrix. MATLAB syntax A plus 10 means that 10 gets added to every element of the A matrix. So 10 is added to every element of A, so that the A11, the first column element, is now 10.8147. So MATLAB adds this 10 to every element of A matrix. B equal to twice of A means that MATLAB multiplies every element of A with 2. So this is the same A here. So twice of A means that every element of A is getting multiplied with a 2, and you have this B matrix with this operation, twice of A. The syntax dot slash in MATLAB means that a reciprocal of every element of A is to be computed. So C is a matrix whose entries are reciprocals of the entries of A. So take the 1 element of A, which is 0.8147. Its reciprocal is 1.2274, is the 1 element of the C matrix. Likewise for all other elements. inv is a command which computes the inverses of square matrices. Since A is a square matrix and it's well conditioned, inverse of A may be computed. Inverse of A is assigned to A underscore inv. So this is the inverse matrix of A. This is the MATLAB main window. It has several sub-windows. This window is the workspace browser, the list form, where we can see all the variables and their value. Their min and max entries here may be seen. To view a particular variable, we double-click it, and the workspace browser's view form opens, and we can see the entries of that requested variable in the cells which appear in the workspace browser view form. So this B that I have clicked has a matrix of size 3 by 3 and whose entries are seen here. This is the MATLAB command window where we do computations. Let's talk about MATLAB's complex numbers. I and j are imaginary units. I squared equals -1 and j squared is also -1. If I seek square root of -1, then MATLAB returns 0 plus 1i. The reciprocal of I is -i, as we know. The command whos, WHOS, returns the current active variables on the command window, their index sizes, the memory sizes, and the class of the variable. Since all of the computation currently is set to double precision, all elements in the current view are of class double precision. So the sizes, the index sizes, and the variable names may all be seen using the whos command, WHOS. Let's talk about MATLAB's complex numbers. A complex matrix D of size 4 by 4 is created by using the ran command twice in this fashion. Since I is the imaginary unit, ran 4 plus I times ran 4 produces a random matrix of size 4 by 4 whose entries are all random, complex random numbers. So D is a 4 by 4 complex matrix. So this matrix is non-singular, so inverse of D is computable here. So inverse of D is this complex matrix. The command magic produces a magic square. It takes for argument n a natural number, a whole number, positive whole number, and it produces an n by n matrix whose entries are integers going from 1 until n squared. The magic square is such that the row sum, the column sum, and the diagonal sum for these squares is all the same number. So magic command works for all n except when n is 2. So let's look at some magic squares. So magic 4 is the magic square of size 4 by 4. So this is the magic square. It may be verified that the row sum, the column sum, and the diagonal sum of the E matrix is 34. So it's a magic square indeed. So let's look at the index ring of such matrices, of any matrices. So E1, 2 is the first row, second column element of E. So here 2 is that entry. So it is returned to the default workspace variable called ans. So if I seek E2, 4, the second row, fourth column entry, so 8 is that number. Second row and fourth column entry is here, 8. Size of E is a 4 by 4. It's a 4 by 4 matrix. And if I seek an entry which doesn't lie within the index size, I'm seeking E2, 5. 5 is larger than 4. So index goes all the way from 1 until 4. So E2, 5 doesn't exist. So index exceeds the matrix dimensions. So this doesn't make sense here. MATLAB takes indices from 1 until the end, the largest size of the index. So E0, 3 also does not make sense because MATLAB doesn't recognize 0 index. The smallest index MATLAB recognizes is 1. So E1, 2 here is 2. And using the dot slash operation, MATLAB computes the reciprocal of every element of E, so which is computed here. The determinant of E is a very small number. It's close to 0. Let's look at the eigenvalues of E. So eigenvalues of E shows that 0 is an eigenvalue. The other eigenvalues are non-zero. So if I compute the E, because one of the eigenvalues is close to 0, inverse of E needs the reciprocal to be computed, determinant to be computed. The inverse of E is a matrix with very large entries. So matrices which are close to singularity, that is determinant being 0, cannot be inverted. So the goodness of a matrix for inversion or away from being singular is measured by the so-called condition number. So because E has 0 as an eigenvalue, it is an ill-conditioned matrix because its condition number is 10 to the minus 17. A good conditioned matrix will have an index, will have a condition number close to 1. An ill-conditioned matrix will have an condition number close to 0. So the condition number of E is close to 0 and the inverse is having extremely large entries. It turns out that the even-sized magic squares, that is magic squares of sizes 4, 6, 8 and so on, are ill-conditioned. They always have 0 as an eigenvalue. Let's look at further indexing of the E matrix. E1, colon is giving me the first row and all columns of E. So that's what is highlighted by this box here. The first row is highlighted. If I seek E colon, 2, if I use this syntax, it gives me all rows and second column of E. So the second column is highlighted here, which is returned when this command is used. E colon, 2. If I use the colon operator in the following way, E2 colon 3, 1 colon 3, it returns me second until third rows, first until third columns. So second until third rows and first until third columns. So this matrix is cut out from the E matrix and returned to the workspace variable ans. Likewise, this syntax 1 to 2, 1 colon 2, 3 colon end takes the last value that the index can take. Here it is 4. So E1 colon 2, 3 colon end gives me this matrix from the first and second rows and third and fourth columns. It cuts out this particular matrix highlighted here and returns to the command window variable ans. Other ways of creating row vectors is the colon operator used in the following way. F is defined to be 0, colon 10, colon 10, 100, produces a row vector starting from 0 and ending with 100 with steps of 10, increasing in steps of 10. G is defined to be 100, colon minus 10, colon 0, is a row vector beginning with 100 and ending with 0 with steps of minus 10.